How did Earth shape? The story of Earth really goes back to the formation of our solar system. Our solar system formed when large clouds of dust and gas contracted. That formed the sun. And the sun was made out of leftover material from probably a star that exploded a long time ago. Once the sun was formed, the materials that were left over shaped the inner planets. That was mostly dense material. That's why the inner 4 planets, the terrestrial planets, are all rocky and dense. Whatever material was left over after the formation of the terrestrial planets escaped even further out into space to form the gas giants. Those are the outer planets from Jupiter out that are large and gaseous. So Earth, being one of the terrestrial planets, initially started off as a really hot object, and it slowly cooled down and eventually formed into the blue planet we recognize today. But I didn't tell the story about how Earth got its shape. That's really the question. Why is Earth round? And you could go even further and ask, why are almost all celestial objects round? Why? Probably the most important force acting on all objects in the universe is gravity. Now, gravity was something that Sir Isaac Newton is famous for. The apple falling from the tree, that's a portion of what he discovered, and he actually expanded on Galileo Galilei's work, who also was able to deduce that gravity was a force of attraction. So because gravity is a force of attraction, any two objects in the universe, in space, feel a pull towards one another. You feel a pull towards every object that's surrounding you right now, but because you're so insignificant in terms of mass, that force isn't that strong. But you do feel a force of attraction to the Earth. That's why things fall back to Earth. So in the formula of universal gravitation, one of the things Newton said was, the closer two objects get to each other, the stronger the gravitational force between them. He also said, the larger two objects are, the stronger the force between them. So those are the two things at work that determine the force of gravity. How far you are from another object, and how big you are. So with that in mind, why the Earth is round has a lot to do with how big it is. Because the Earth is so big, the outer edges of the Earth are attracted to the inner edges. And this force of attraction is literally squeezing, trying to squash the Earth inwards. And that helps force the Earth into a sphere. If you look at some other objects in our own solar system, they're not spherical. These are the two moons of Mars, Phobos and Deimos. Phobos is on the left, Deimos is on the right. Phobos is 22 kilometers wide across the diameter, and Deimos is 12.6 kilometers wide across the diameter. The point I'm making here is that both objects are not big enough to be squished by gravity, and therefore they're not spheres. They're kind of potato-shaped. And the rule is in order to be spherical, you have to be a certain size. So the Earth is big enough, along with many other objects in our solar system, be spherical from the force of gravity. But there's actually another force at work that shapes the Earth, and it's hard to spot. If you were to take a measurement from east to west across the Earth, the diameter is 12,765 kilometers. If I were to measure the distance from the North to the South Pole, I get a very different measurement. That's 12,714 kilometers. So there's a problem there. If Earth was a perfect sphere, a perfect circle, those numbers should be equal. Earth is fatter at the equator, wider at the equator than it is at the poles. So the Earth is actually a different kind of shape altogether. That shape is called an oblate spheroid. Now, how does that happen? How does it become oblate? Now, the best answer I can give you is pizza. Why pizza? If you've ever seen a baker make pizza, they do something like this. They take the dough and they throw it up, right? They spin it. Now, why do they spin it? Because as they spin it, it widens out. So on Earth, that motion is called rotation. And because of rotation, the Earth gets flatter at the equator. It bulges out because as it's spinning, that force causes it to widen. So if you take into account both forces, the force of outward movement from spinning plus the inward force of gravity, you have the two forces that shaped Earth, that made Earth an oblate spheroid. Right now, the Earth is at a dynamic equilibrium. That means it's no longer getting wider and no longer getting squished. But that is how Earth got its shape. And that's how most objects in space got their shape, if they're spherical. So that's it for now. Thanks for watching.